Create buffers, name the buffer storage, bind the buffer to its target. Create vertex arrays, bind the vertex array. Enable vertex attrib array, vertex attrib pointer. Create buffers, name the buffer storage, bind the buffer to its target. Create vertex arrays, bind the vertex array. Enable vertex attrib array, vertex attrib pointer. Hi everyone, my name is Thomas Kim. Today is April 7th, 2023. This is my 41st episode for C++ electricity and magnetism. In this episode, we will learn vertex array object, vertex buffer object, vertex attrib array. To follow my current and future sessions, you need this command prompt, also this command prompt, also this command prompt, also this command prompt. These are all different command prompts. To create such command prompts, you have to watch my previous videos listed here. Also, you can download command prompts and icons by clicking this link. In this folder, if you unzip icons, you can find these command prompts. These are all command prompts. You can get these command prompts by clicking this link. Also, I assume you have installed GL Tools, OpenGL Programming Guide 9 Tools, also OpenGL Superbible 7 Tools. You can get these tools by using these links. For example, GL Tools. You can download GL Tools. Also, OpenGL Programming Guide 9 Tools. Also, OpenGL Superbible 7 Tools. You may also need updated C++ library extensions. By double-clicking, you can download C++ library extensions too. Show in folder. If you unzip these zip files, then you can install like this. And by watching my previous videos listed here, you can make proper environment variables for such command prompts. Otherwise, you may not be able to follow my current and future sessions. Learning OpenGL 4.5 or 4.6 is quite challenging, but once you memorize OpenGL songs, you can understand what is vertex array object, vertex buffer object, vertex attrib array. If you become proficient with these things, up-to-date OpenGL programming is doable. Without further ado, let's get started. Open up Visual Studio Code, Electricity and Magnetism. Select Empty Folder. Click this button, 041 Triangles. Click this button, Triangles. Vertex. Click this button, Triangles. Preg. Click this button, Triangles. .cpp. Hit Enter. I will install icons. Visual Studio Code icon. Install. Activate. Now we can see pretty icons. Ctrl V. I will restart. Now you can have pretty icons. Ctrl V. I will select triangles.cpp, include CPG, SED extensions, include OpenGL Programming Guide 9 HPP. Begin app declaration. This is class name. Triangles and app declarations. Define app. We provide the class name here. Then title of our application, triangles. Then int main row h instance 2: get module handle null semicolon win main h instance null sw show Ctrl Shift P edit configuration JSON. You need to set these environment variables. OpenGL Programming Guide 9 Inc. OpenGL Superbible 7 Inc. These environment variables should be created. Environ edit system environment variables. In this section, OpenGL 9 Inc. These environment variables should be created. OpenGL Superbible 7 Inc. This path should be resolved. Otherwise, you cannot use IntelliSense. With this, we will use this pretty bug. You should see Intel SQL OpenGL Programming Guide 9th edition. This command prompt message. dir cd 041 triangles. Here icxcl triangles.cpp oi.exe. We need qsed C++20 ehsc. We need md switch app NoSQL. We need link SUBSYSTEM console. Hit enter. cls dir i.exe is created. So we have this triangles window. Now close it. So this is the command string. It's very ugly. Now I will paste it here. Instead of doing this, I will create response file resp.txt. Hit enter. Ctrl V. From this file, we can use this text. In the resp.txt, we don't need this part. Then in the command prompt again, we can do like this. icxcl star cpp at resp.txt. Hit enter. Then we can build I. Now close it. I will close this JSON file. Also this response file. Select Begin App Declaration. Right click. Go to Definition. In this section, Begin App Declaration is defined with the argument app class. This macro creates a class called app class. Its base class is Vermilion application. In the class app class, it defines base as the base class of this app class. So we will need this base. Now Vermilion application, right click, go to definition, double click it. We will arrange side by side. Vermilion application defines initialize this virtual function. So public faced override. We have to call base initialize title. We also need to define display virtual function. This should be override. Sorry, here override. We have to call base display auto redraw because this display in the base class Vermilion application, it calls glFW swap buffer. So don't forget calling display in the base class. We also need finalize. Paste it here. Override. We will flash out these virtual functions. Now we can close it. In this section, we will build a program. Then we need private GL unsigned int program. I will initialize with the default value. Then load shaders. We pass shaders. We haven't defined shaders. Shader info shaders. This is array. Each element of the shader can be GL Vertex shader. Then we provide this file name triangles but comma copy paste. Now GL fragment shader frag copy paste. It can be 0 null, or we can say GL none. GL none is defined to be 0. Now we create two shaders. This is Vertex shader version 460 core. Copy this, paste it here. We are using up-to-date OpenGL technology. For the main, we will define layout location 0 in glPopMatrix position semicolon. Please understand, V position is called Vertex attribute or Vertex Attrib. We will use V position as Vertex Attrib array. You have to remember what Vertex Attrib array means. V position is Vertex Attrib array. With this, GL position, V position, we created very simple triangle vertex shader. Now here, out backpo, we say fragment color. For the main, fragment color can be backpo. I will select arbitrary color For example, 1.0 app, 1.0 app, 0.0 app, 1.0. Because this is backport, I have to put app here. With this, we can build program. Now, GL user program. We select program. Now, OpenGL Programming Guide. This is 9th edition. In this book, this button, Chapter 1, first look at OpenGL program. If you scroll down, you can find Figure 1.1. We will be creating this program. Scroll down, you can find vertices. Copy, paste it here. I will indent like this. 1, 2, 3, 4, 5, 6. So context per GL size I num vertices. It will be set to 6. So we defined num vertices. This is type float. I will fix like this. Fix your code like this too. Then I will arrange to make it look pretty. This represents a single vertex. Each vertex has 2 elements, so 2. It should be static. Now here we create buffer to hold these vertex arrays. So GL create buffers size I n. We are creating a single buffer. Then vertex array buffer. It should be address. Copy, scroll up, paste. It should be GL unsigned int. I will initialize with the default value. With this declaration, we created buffer for vertex array. Now I will sing a song for you. Create buffers named buffer storage. Bind the buffer to its target. Once again, create buffers named buffer storage. GL named buffer storage. GL unsigned int buffer. This buffer. Then GL size I ptr. This represents buffer's byte count. We can compute the memory byte size of vertices. Then data. Data is this vertices. Then GL bit field. We can set 0 in this episode. Once again, create buffers named buffer storage. Bind the buffer to its target. GL bind buffer target. We'll use this buffer for array. So GL array buffer. GL unsigned int buffer. This buffer. In this case, we copy vertices, the contents of these vertices, to GPU buffer. Copy host memory vertices to GPU memory vertex array buffer. Then select or activate the buffer. This vertex array buffer. Because buffer song is very important, I will sing this song once again for you. Create buffers named buffer storage. Bind the buffer to its target. Please note that here we created a buffer to hold vertex array. This vertex array in the GPU device. Then we allocate GPU memory and copied. We allocated GPU memory and copied host memory to GPU buffer. Then we selected or activated the GPU buffer called vertex array buffer. Now we need vertex array object which manages the state of our GPU buffer or vertex array buffer. For such purpose, we need to create vertex array object. Create vertex arrays bind vertex array. GL create vertex arrays. We need to create at least one or more vertex array object. We pass vertex array object. Copy in the private section GL unsigned int vertex array object. Now scroll down. This vertex array object manages the state of the active vertex buffer. This vertex array buffer, we have to bind this vertex array object. GL bind vertex array by passing array. This array means this vertex array object. Please understand, we created host memory, then copied to GPU vertex array buffer. Then we bound vertex array buffer to target, GL array buffer target. We created vertex array object. This vertex array object manages the active vertex buffer. Active vertex buffer means GL bind buffered vertex array buffer. Now we need to feed from vertex array buffer to vertex attrib array V position. We can extract its position, the location 0 like this. Or V position GL get attrib location. This position is vertex attribute or vertex attrib. So get attrib location. We are extracting this location 0 by providing program, then the variable name in the vertex shader like this. Now let me sing vertex array song. Create vertex arrays bind vertex array. Enable vertex attrib array vertex attrib pointer. Once again, create vertex arrays bind vertex array. Enable vertex attrib array vertex attrib pointer. So GL enable vertex attrib array. We pass this position. Now V position vertex attrib array is enabled through enable vertex attrib array. But there is slight problem. In this case, our CPU host memory, this is a single vertex. our single vertex has two elements of type GL float, but this vertex attrib array is back 4. It needs 4 elements, but our host memory, the vertices, each single vertex has 2 elements, but in our vertex shader, V position requires 4 elements of back 4. That's the problem. To solve such problem, we need vertex attrib pointer. Create vertex arrays, bind the vertex array, enable vertex attrib array, vertex attrib pointer. So GL vertex attrib pointer index. This index represent vertex attrib arrays index, the location. This location we extracted V position, so it should go here. Then GL int size. Please understand, our host memory, each vertex has 2 elements. Our vertex attrib array V position takes 4 elements, so we have to inform OpenGL that each vertex composed of 2 elements. We provide 2. Then type. Our vertex type is float. So GL float. No. It should be GL float. Then normalized. In our case, all our vertices are normalized. I will discuss more about normalization in future. So GL false because our vertices are already normalized. Then stride. Our memory is contiguous, so stride is 0. Then GL void pointer. This is offset. Offset is, for the time being, 0. I will sing vertex array song once again. Create vertex arrays, bind the vertex array, enable vertex attrib array, vertex attrib pointer. Everything is ready. Now we can draw our triangles. Now in the function display, GL plot erase color. This is array. I will simply use 0001, the black color. GL clear buffer FB. GL color draw buffer. Default is 0. Then erase color. GL draw arrays. GL triangles. First index is 0. Count num vertices. Don't miss calling base class display because in this function Vermilion application display in the base class calls glFW swap buffer. So you should not miss this. Now scroll up. We will free all these things. GL delete program. We pass program. I will delete. GL delete buffers. We have to pass count. Then this buffer with address gl delete vertex arrays. One vertex array object here. Now we completed our program. We will rebuild CLS I. Wow, amazing. Now close it. Open this pretty bug. CD 041 triangles. We are now using NVCC compiler, NVCC STD C++20 triangles.cpp on.exe x compiler. We have to pass md x linker subsystem console. Hit enter. Wow, we built using Nvidia CUDA NVCC compiler. Control home, paste it here. Now CLS dir n. We can also build successfully using CUDA NVCC compiler. Create buffers, name the buffer storage, bind the buffer to its target. Create vertex arrays, bind the vertex array. Enable vertex attrib array, vertex attrib pointer. Create buffers, name the buffer storage, bind the buffer to its target. Create vertex arrays, bind the vertex array. Enable vertex attrib array, vertex attrib pointer. Create buffers, name the buffer storage, bind the buffer to its target. Create vertex arrays, bind the vertex array. Enable vertex attrib array, vertex attrib pointer. Create buffers, name the buffer storage, bind the buffer to its target. Create vertex arrays, bind the vertex array. Enable vertex attrib array, vertex attrib pointer. Create buffers, name the buffer storage, bind the buffer to its target. Create vertex arrays, bind the vertex array. Enable vertex attrib array, vertex attrib pointer. Create buffers, name the buffer storage, bind the buffer to its target. Create vertex arrays, bind the vertex array. Enable vertex attrib array, vertex attrib pointer. Create buffers, name the buffer storage, bind the buffer to its target. Create vertex arrays, bind the vertex array. Enable vertex attrib array, vertex attrib pointer. Create buffers, name the buffer storage, bind the buffer to its target. Create vertex arrays, bind the vertex array. Enable vertex attrib array, vertex attrib pointer.